Good evening, everybody. We have completed the topic gradually varied flow. What we have studied in gradually varied flow, if you look back, what are the assumptions of gradually varied flow equation? That are very, very important. Once that is completed, what is the general equation of gradually varied flow? That is dy by dx is equal to S0 minus SF divided by 1 minus Q square T by GA cube. This is what we have studied. This Q square T by GA cube is nothing but Froude number square. So S0 minus SF divided by 1 minus FR square is equal to dy by dx. This is what the general equation of gradually varied flow. Now, what is this dy by dx? Dy by dx is the water surface slope with respect to channel bottom. Right. What is S naught? It is the bed slope of the channel. That is measured with respect to what? Horizontal. What is SW? Again, water surface slope measured with respect to horizontal. Next, what is SF? Energy line slope measured with respect to horizontal. All suffixes S not means bottom slope. W is means water surface slope. F means energy line slope. S0, SW, SF all are measured with respect to channel bottom. But dy by dx, which is the equation for gradually varied flow, is measured with respect to channel bottom, not horizontal. This is the first thing you remember. In the case of uniform flow, this S0, SW, SF all are same. All are same. All are parallel to each other. So there is no distinction between S0, SW, SF. That's why when we talk uniform flow, we don't talk anything about water surface slope. We don't talk anything about energy line slope. Only bed slope we take and use the Chegis and Manning's equation and complete. That is why whenever you are solving a problem related to uniform flow, S naught is the only slope which is required. That's all. Because SW, SF have no role, all are equal. That is first. And the depth of flow in uniform flow is always called normal depth. That is YN. That is next point. Then coming to gradually varied flow. So what is the relation between SW and dy by dx? SW is what I mentioned. It is the water surface slope with respect to horizontal. What is dy by dx? Water surface slope measured with respect to basically the channel bottom. So what is the relation between these two actually? So that also you can find out. SW is equal to S naught minus basically dy by dx if the water surface slope is rising, and SW is equal to S naught plus dy by dx if the water surface slope is falling. So this is what we have studied. So that is complete. Then actually, because general equation it may not be really applicable to do problems, because problems you need the shape perfectly so that you can calculate area, you can calculate perimeter, you can calculate the hydraulic radius, you can calculate the hydraulic depth. So that is why we always work on rectangular channels. So when I take a wide rectangular channel, wide means in your mind it should come river, where the width of the river is so large compared to the depth there. So that is why we take the width itself is equal to perimeter in case of a wide rectangular channel. So for that we have done it. What we have done there actually, if you see it, S naught in dy by dx is equal to S naught into y 1 minus yn by y whole to the power of 10 by 3 divided by yc by y whole cube. That is what we have done. If suppose you use Chezy's equation, instead of yn by y whole to the power of 10 by 3, it will be yn by y whole cube. That's all. There is no other change. So that equation also I have done. So with that, I stopped. That is one part of the things are over. Then I have taken how to classify the channel bottom slopes. The channel bottom slopes, how they will be classified? They can be classified with respect to bottom slope. If S0 is less than critical slope of the channel, then we call it as mild. S0 is greater than SC, we call it as steep. S0 is equal to SC, we call it as critical slope. S0 is basically 0 horizontal channel. S0 less than 0, we call it as adverse channel. This I mentioned. Then what is the relation when the S0 SC relation you have told? What is the relation between Yn and Yc? When the S0 is less than SC, automatically Yn should be greater than Yc. S0 is greater than SC, Yn should be less than Yc. S0 is equal to SC, Yn is equal to Yc. Then S0 is equal to 0, then Yn is infinity. S0 is negative, then Yn is imaginary. So this is the picture regarding channel bottom slopes. Once the channel bottom slopes are clear to you, then think of water surface slopes. So how to classify water surface slopes? The water surface slopes are broadly classified under two headings. One is called as backwater curve, the other one is called as drawdown curve. This backwater curve we continuously hear in so many occasions in many reservoirs. So backwater curve, when they will form, suppose when an obstruction is constructed across a river, the flow upstream of the obstruction is a backwater curve. That means when the flow is taking place at uniform flow, that means the depth is constant. Suddenly there is obstruction has come. So because of the obstruction, there is a water surface rise. Water surface rise actually that happens. That rise in the water surface profile is what we call it as backwater curve. If the water surface rises in the direction of flow, we call it as the basically backwater curve. When the water surface falls in the direction of flow, we call it as a drawdown curve. Then what are the characteristics? A backwater curve, naturally, when it is a rising curve, I mentioned, then naturally dy by dx is positive. When it's a falling curve, I mentioned, dy by dx slope is negative, minus. So this you should remember. Right? When this drawdown curve occurs, suppose when there is a sudden change in channel bottom, then the water surface suddenly drops. So that's why water surface profile drops. That is what we call it as a drawdown curve. When there is a change in bed slope, automatically the drawdown curve appears. When there is an obstruction across the river, the backwater curve appears. This is what we have studied. So that is broad classification. But a more detailed classification is studied with respect to channel bed slopes. Already I mentioned channel bed slopes are 5: mild, steep, then critical, horizontal, adverse. With respect to each of them, the water surface profiles are classified. That is also I mentioned. In mild slope channel, there are 3 water surface profiles, which we call it as M1, M2, M3. Whereas in steep channels, we call it as S1, S2, S3. Whereas if you take it critical slope channel, the middle one merges because NDL and CDL, both normal depth line and critical depth line, coincide with each other. So it is C1 and C3 only. When you go for horizontal channel, the Yn is at imaginary. So what is there above Yn? Nothing is there. So that is why it is only between Yn and Yc basically. That means above CDL, below CDL. So there are only C2 and H2 and H3. Whereas even adverse channel yn is imaginary, so it is also a2, a3. And what type of curves they are, what is the relationship between y and yn, yc, that also I have shown. So this is what we have studied. Then the last point what we have studied actually. So the last point is, suppose now, okay, because of the obstruction, there is a backwater curve. Because of the what is the extension of this backwater curve? To how much length in the reservoir or river on the upstream this backwater curve extends? That we want to know. How to know about it? To know that actually, that is where how to calculate the length of the backwater curve, that is direct step method or single step method or step method, that I have taken up and I have solved the problem to you regarding that. So this is what we have studied in the entire topic actually till now. So in this class also some 2 3 problems I will do, and I will close this topic with a small definition at the end of gradually varied flow. Right? Let us go into doing some of the problems. So you to get you familiarized with the whatever I talked just now, to familiarize with those. Suppose when you call a channel as a mild slope channel, if you want to know what type of channel it is, then you should know what is yn, you should know yc. Yn and yc, if you know, comparing yn and yc, if yn is greater than yc, mild slope. If yn is less than yc, steep slope. That is how you classify. So how to calculate yn? Yn means assuming the flow is uniform. If the depth you are calculating, it is yn. Yc, how you calculate? We know the equation for Yc. For rectangular channels, Yc is equal to small q square by g whole to the power of 1 by 3. What is small q? Small q is nothing but discharge divided by the bed width of the rectangular channel. So like that you calculate Yn, you calculate Yc. Then once you calculate Yn and Yc, compare these two, and depending on the relative values of Yn and Yc, classify whether the channel is mild or steep. Once you classify that, then you find, suppose what is yn, you know, what is yc, you know, where the profile is. So if you know where the depths are, if suppose the depths are above yn yc, then m1 profile. If the depths are basically between yn and yc, the profile is m2 profile. If the depths are such that they are below completely yc, then naturally it is m3 profile. Same is the channel with steep slope. So this is one of the very important questions that you should know. So that is exactly which I have done also in the previous lecture. Apart from that, the length of the profile also I have done it. So these are the questions that we have. So you have different techniques actually to solve the problems also. So one more technique also I will show you now in this problem, basically, because even in that equation also, equation is very simple. Dx is equal to E2 minus E1 divided by S0 minus SF dash, right? So what is E2? E2 is the specific energy at section 2. What is E1? Specific energy at section 1. What is S0? Bed slope. What is SF dash? It is only the average of the energy slope. So the average of the energy slope, previously how I calculated? I calculated at first section what is SF, what is the SF at the second section. I take the average of these two. Even you can do that also. Rather than calculating at two sections, you can take at midsection, and at the midsection also you can calculate SF. That is what you can use it as SF average. So like that, depending upon the time available, you can do problems in different ways. But you should know the principle how I am applying the things. So let us do some more problems to familiarize with this and close this topic actually. Thank you. So let us straight away take the problem continuation to the previous one only. I will take a river 90-meter wide and 3 meters deep, has stable bed and vertical banks with a surface slope of 1 in 2500. Estimate the length of backwater curve produced by an efflux of 2 meters. Assume Manning's N 0.035. A river 90 meters wide and 3 meters deep has stable bed and vertical banks with a surface slope of 1 in 2500. Estimate the length of backwater curve produced by an efflux of 2 meters. Assume Manning's N 0.0. How I will show you also stable. This is the length of the backwater curve. Backwater curve means actually unless an obstruction is there, the backwater curve. So how the backwater curve, this is how it is. So here it is basically y1, this is y2. You understand? Y1. And what he wants, what is this length? This length, backwater curve length, this is BWC length. This is what he's asking us. Right? So now what he has given basically a river wide 3 meters deep has a stable environment and estimate the length. F flux is basically F flux 2 meters. That means the change F flux means what? F flux is nothing but Y2 minus Y1 is equal to 2 meters. What is Y1 already he has given? It is 3 meters. So Y2 should be how much? 3 plus 2, it is equal to 5 meters. So this is the first thing. So now two sections are clear. One is this section, one is this section, and we want what is the distance between the two sections, right? Now with this background, I will take you to this. B is equal to 3 meter. What is B is equal to? He has given 90 meters. Sorry, 90 meters, right? Y1 is equal to 3 meters. This is first thing. Then what he has given SF is equal to, he has given it as surface slope 1 by 2500 and N is equal to 0.035. These are the things that are given. Right? Now if I calculate what is area, A is equal to BY 90 into 3, 270 meters square. What is P? 90 plus 3 plus 3. So 96 meters. What is R? Actually 270 divided by 96. R is equal to 2.81 meters over. Then knowing APR, basically Q is equal to A into 1 by N into R to the power of 2 by 3 SF to the power of half. Right? If I take this, what is Q? A is equal to 270 into 1 by N means what? N is equal to 0.035. What is R is equal to 2.81 whole to the power of 2 by 3. What is SF? 1 by 2500 whole to the power. Therefore, calculate Q is equal to, you're going to get 308 meter cube per second. This is first calculation. Because without knowing Q, I cannot calculate what is E1, what is E2. So now let us go. Specific energy at section 1. Specific energy at section 1. What is specific energy at section 1? Specific energy at section 1 is equal to, that means Y1 is equal to 3 meters. So at that place. So E1 is equal to Y1 plus V1 squared by 2G. Right? What is V1 is equal to Q by A1. What is Q is equal to 308, which we find A is how much, 90 into D. Right? This is V1. So now E1 is equal to, let me calculate, it is 3 plus 308 by 90 into 3 whole square by 2 into 9.81. So if I calculate this, it is 3.0663. It is meters over. Then specific energy at section 2. I2 is equal to 5 meters. So E2 is equal to Y2 plus V2 squared by 2G. So E2 is equal to V2 is how much actually? Q by A2. Q is how much? 308 by 90 into 5. Right? So Y2 is how much actually now? 5 plus 308 by 90 into 5 whole square divided by 2 into 9. So how much it is going to be? 5.0239 meters. So this is 1, this is 2 over. Then E2 minus E1 I got. So what is remaining? I got already E1 is over, E2 is over, then S naught is over, because for the first one that is given is for uniform flow. S0 is equal to SW is equal to SF. So now what I need to find out, what is SF dash? This is to be found out. If I found out this, then straight away I can use dx. X is equal to x or dx or L or whatever you call it is equal to E2 minus E1 divided by S naught minus SF dash. So this I can use it and find out what is X. So now SF dash how? So there now I am doing in a different way. Previously what I have done at section 1, SF1 I call. At section 2, SF2 I calculated. Then I take actually the average. This I have taken in the previous problem. So in this problem, I am doing it separate fashion. How I am doing it? Now, basically, I just mentioned this is the profile, right? So this is what? This is 3 meters. This is 5 meters. So now naturally, this is the length. So midsection I have taken. I have taken what? Midsection. Midsection means y is equal to how much? 4 meters, because this is 5, 4. So at 4 meters, I calculated what is calculate what is SF, and I to this is SF dash. So this is also one method of doing it. So that is what I would want to follow in this problem. So how I do it now? So the energy line slope SF dash is calculated at midsection, that is at y is equal to 4 meters. So if I take it 5y, this is 3 plus 5 by 2, that is 4 meters. Right? Now what is SE is equal, SF is equal to, SF is equal to V square N square divided by R to the power of 4 by 3. Right? R to the power of Q square into square by R to the power of 4 by 3. Just what is, check it up. What is Q V is equal, sorry, V is equal to basically 1 by N R to the power of 2 by 3 SF to the power of half. V square is equal to 1 by N square R to the power of 4 by 3 SF. So what is SF is equal to V square N square divided by r to the power. Fine. This is the equation. There is no problem. Right. So now this question is right. So now again what we will do, so SF is equal to, instead of V square is equal to Q square by A square into N square by R to the power of 4 by 3. So already Q square is known, Q is 308 whole square, N is known 0.035 whole square. A is what at the midsection? Midsection is 90 into 4 whole square into R is equal to what? Area 90 into 4 divided by 90 plus 4 to the power of 4 by 3. So if you calculate this, we get it actually 1.58 into 10 to the power of minus 4. Therefore, x is equal to E2 minus E1 divided by S0 minus SF dash. E2 is equal to how much? 5.0239 minus 3.0663 divided by S naught is equal to, that is 1 by 2500 minus, this is 1.58 into 10 to the power of minus 4. So it is 5.0, this one if you take it 5.0239 minus 3.0663, 1 by 2500, also you can make it actually, it is 4 into 10 to the power of minus 4 minus 1.5 into 10 to the power of minus 4. So if you do it, it is coming to 801 by 100 meter. So this is one of the good problems that you can work in. So I have done two problems based on this particular things. So I will take up one more problem also uh, in this chapter. Take the problem, actually the second problem of today's lecture. Find the slope of E water surface in a rectangular channel 15 meters wide and 3 meters deep. The slope of the stream bed is 1 in 5,000. Total discharge is 29 meter cube per second. Assume C is equal to 65 and that the depth is increasing in the direction of flow. Find the slope of the free water surface. This is what the question is, right? So now what is the slope of the, that means gradually varied flow equation. Dy by dx is equal to S naught minus SF divided by 1 minus FR square. This is the question, right? Now, what is FR for a rectangular channel? It is root GD V by root GY, because for rectangular channel, D is equal to A by T, it is equal to BY by B, it is equal to Y. That is Y, right? So now what we need to calculate, what is V? V is equal to Q by A. Q by A means 29 divided by A is 15 into 3. So how much it is? 0.645 meters per second. Then what is F? F for it is V by 0.645 divided by root of 9.81 into Y is how much? 3. This is F1, right? So therefore, what we want to know, what is Fr square? So Fr square is equal to 0.645 whole square divided by 9.81 into 3. If you calculate this, it is 0.0142. Therefore, again, what is SF actually? We know it is V square by C square, or because V is equal to C root RS. So V square is equal to C square RS. Therefore, SF is equal to V square by C square R. This is one. So what is V is equal to? Already you got V is equal to how much? 0.645 whole square. C is how much? 65 square into R is equal to how much? A by P. 45 divided by 21. How you got it? A is equal to how much actually? 15 into 3, 45 meter square. P is equal to how much actually? 15 plus 3 plus 3. So 21 meters. This is what I have substituted. So once you got SF is equal to how much? 1 by 21,700. Therefore, dy by dx is equal to how much? It is equal to 1 by 5,000 minus 1 by 21,700. That is S0 minus SF, 1 minus FR square. FR square means how much it is? 0.0142. So you are going to get how much actually? 1 by 6,400. This is what is the answer. So this is again another question to you for understanding. So now last topic I want to take it as one section. What is control section? The closure of this topic is what is control section? Control section is a section. Control section is a section where there is a definite relationship between depth of flow and discharge. Definite relation between depth of flow and discharge. The best example is critical section. Why critical section? Why at critical section Yc is equal to q square by g whole to the power of 1 by 3. There is a definite relationship. There is a defined relationship. So critical. And what is the use? What is the use of control section? Generally, control sections are used for measurement of flow. For measurement of flow. So this completes the entire topic of gradually varied flow. I stop this topic at this place and go into the last topic of this non-uniform flow, which it is rapidly varied flow. That is in the next class. I will take you to that portion of rapidly varied flow. With that, we complete this. Hope I am amply clear in gradually varied flow completely. So I have done even into depth also all the topics actually. So listen carefully once, twice, thrice. So it will be very easy for you to reproduce in the exams also. Right? All the best to you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.